Hey everyone, welcome to another edition of Can You Hack It? I'm Ben, also known as Iceman, and today we'll be walking through a box on Hackthebox.eu called Valentine. It's a Linux machine with just below a medium level of difficulty. So why don't we go ahead and take a look here. We see that the IP address is 10.10.10.79. So as usual, we'll get started by creating a directory to work out of. Directories into that, and we'll make a Nmap directory so that we can keep all of our scans somewhere. And then we'll fire off Nmap. So we'll do Nmap-T5 to make it aggressive, SC and SV to enumerate versions, run scripts, OA to output all formats to Nmap/quick, V so that we can see it as it's running. And then 10.10.10.79 is the IP address of our box. And so we can see right away that we've got port 22, 80, and 443 open. So we've got SSH and HTTP and HTTPS. It's going to go ahead and enumerate these and give us the versions that are running. So Apache HTTPD 2.22 running on Ubuntu. We can take a quick look here. Apache 2.2.22. Yes, I can forget that quickly. And I think if we take a look at should have thrown Ubuntu in there. Here we go, that's probably the right thing. No. You'd think one of these days I would remember exactly where to find this. Basically you can look and see which version of Ubuntu we're running. Actually I happen to see it there. Uploaded to precise, so this is probably close enough. So this is probably running precise, which is 12.04 maybe? Yeah, 12.04.5. So it's a fairly old version of Ubuntu, which means that we may be able to use some exploits to get priv on here once we get to that point. But for now, let's actually take a look and see what it's serving on these web pages. 10.10.10.79. And this is interesting, so it's a little cartoon looking graphic. This happens to be the logo for Heartbleed, which if you followed that when it was initially discovered, you probably recognized also. And so that combined with the name of the box gives us a pretty good clue on at least one technique we're going to use on this box, which is using Heartbleed to do some reads of memory. But for now, let's actually get a, let's start fuzzing the website, seeing what we can find as far as files and directories that are available on it. So for that, I'm going to go ahead and use gofuzz. As I pointed out before, I haven't actually released this tool yet. Hopefully soon. It's one of those things where it keeps getting backburnered by other stuff that's going on. I may release it in binary format temporarily. Biggest thing is I don't want to put up the source until I clean it up because it's kind of embarrassing right now. So the first flag that I'm giving is hide response codes of 404. So basically show me anything that's not a 404. And then we'll do a show full responses. So we want to see the entire URL, not just the word from the word list that happened to match. -R for recurse, so we want it to explore directories that it finds. EXT for extensions, and we'll just do PHP for now. W for word list. User share, we'll use the typical dirbuster word list, which is in word lists. Dirbuster, directory list. 2.3, and we'll do medium. I think small actually works fine on this one too. For those of you that aren't already aware, all these word lists are part of Kali, so you should have them by default. Sometimes I use word lists that are part of sec lists, or some other ones that aren't there by default, but this particular one should be. -T for threads, and we'll do 100 threads, which is pretty aggressive, but I found to be fairly reliable on the Hack the Box boxes. It's capable of going much faster than that, but we have a tendency to get broken sockets, and then things go wrong, so we don't want to get too aggressive. And then we'll use our URL here, 10.10.79/79/fuzz. And so what it'll do is it'll replace where it says fuzz with words from the word list, adding the extensions onto it, so similar to wfuzz if you've used that before. So we'll go ahead and hit enter and get it started. Looks like it's found a couple already indexed in index.php. And while we're waiting on this, actually looks like it found a few more. Let's see if we can find heartbleed Python. Find a script that we can use to test and see if the server is vulnerable to heartbleed. There may actually be some built into Kali as well, but for now we'll just use this one as I've used it before and it works fine. Get a raw view, we'll take everything that's in here, copy it, and we'll open a new tab. We'll do vim heartbleed.py. We'll paste that in, we'll write it, and then we do python heartbleed.py. And so it gives us some options here. And so what we'll want to do is run, let's see, the host 10.10.10.79 and then -p for port, and that's 443. We'll run this without any other arguments, so we're basically just going to check to see is it vulnerable or not. And so as you can see here, server returned more data than it should. Server is vulnerable. And so that means that it is vulnerable, and we can likely see if we can get some useful information by performing the attack against it. So what this is basically, just in a quick line, is it's a buffer overread in openssl, and so we're able to read past where the buffer is and just read random data that's in memory. Hopefully we can find something useful in there. For now though, let's see, let's go back to our gofuzz and see if we finished up yet. Doesn't look like we've fully finished up, but it looks like we've found quite a lot of stuff. So it looks like we've got a dev directory, and inside that dev directory we have a hype_key and a notes.txt. Then we also have an encode.php and a decode.php. So let's take a quick look at encode and decode.php. So secure data encoder, no data is stored on our servers. If we type in like the video, hit submit, it looks like it encodes it. That looks like it's probably base 64. We don't have the normal telltale padding, but I'm willing to bet that it is. So we click on use the decoder. It switches us over to the decoder now. We paste that in here. It should decode back to our like the video. So the encoder decoder appears to work. Let's add some extra jump just to see what this is. Yeah, so this is base 64. It's adding the padding on the end. So that may be useful for something. We've got a notes.txt file, so we can take a look at that. By the way, if you've noticed, in gofuzz, all of the things it finds are clickable, and so you can just control click. To do coffee, research, fix a decoder encoder before going live, fix the encoding decoding, make sure it's only client side, and do not use until all of this is done. So it's likely that there is an issue in the encoder decoder. Again, based on the information we know so far, such as it's vulnerable to heartbleed, and that this person's concerned with making the encoding decoding client side only, it makes me think that their concern is that we would be able to retrieve information that was encoded or decoded from the buffer in the web server. And so why they want to do it client side, you wouldn't have that vulnerability. So my guess is, based on the pieces we've found so far, we're going to end up retrieving some special piece of information out of the web server's memory that has to do with this encoding decoding process. And there was one more interesting one in here. By the way, this is a bug still. If the line is longer than the terminal line, even though it's a 404, it ends up showing up. And these word lists have some interesting stuff in them if you've never looked at them. So last thing here is hype key. And this looks like just some bytes, space separated. So what we can try and do here is see if these happen to be ASCII encoded text or something. We can manipulate it in Python. So let's kill out of this for now. I think we found everything that we need to find. Before I decode that, let's just take a quick look. So OMG, that's our image from the home page. I already looked at all the rest of this stuff. So let's run Python. There's a million ways you can do this. Also, personally, I just find it easy a lot of the time to pop open a Python terminal and just kind of do things interactively. So we do, let's do, what was this called, hype key. So we'll do hype bytes equals 3 quotes so that it doesn't close or error out on our new line. Paste this in, 3 quotes. So now we have hype bytes. That's our hype bytes. And so obviously the first thing we're going to want to do is pull all these spaces out of here. So hype bytes is equal to hype, hype bytes dot replace. And we'll replace spaces with nothing. So now if we look at hype bytes, we've got what looks to be a hex string. And so if we do hype ASCII, and we just try and do a simple decode on it, hype bytes decode hex, and then if we look at hype ASCII and see if it's actually something readable, and it is. And if you recognize this, it looks like it's a RSA private key. Let's go ahead and write it out to a file so that we can play with it more. Open, we'll call it please subscribe.key. Shameless plug. And then we'll do out.write, and we'll write hype ASCII, and we'll flush it, and we'll close it. We'll quit out of this. And so now if we do an ls, we've got please subscribe.key. If we cat that, what we can see we have here is an RSA key, and it looks like this one is encrypted, as we can see here. And so it's not actually usable to us without a passphrase. So initially I was thinking maybe we found a key that we can use to SSH. We may have found a key that we can use to SSH, but until we get the passphrase that was used to encrypt this key, it's not of a whole lot of use to us. So for now, we'll just go ahead and set this to the side. And what we'll do is we'll try running our heartbleed tool and see if we can't find anything interesting in there. So remember, it's python heartbleed.py, the IP address of the host, P for the port, and then you can give it a number of iterations to run for dumping memory. So we'll just do 20 to start out with. It's just arbitrary. You can do more, you can do less. 20 seems fast enough. So, and then if we look in here, a lot of this is not super interesting, kind of just random junk out of memory. I did see a couple spots though. So here it looks like we're seeing the tail end of probably an IP address like 127.0.0.1, so the person running it locally. Decode.php content type is a URL encoded form, and so this is probably post data, and we see text equals, and it looks like a base 64 encoded string, and so they were passing it to that decode.php page. So if we take this and we go back to our decode page, which I don't actually remember, but we can do this, and that decodes to heartbleed, believe the hype. And so what we can try and do with this is see if it works for decoding that the RSA key that we found. So just a quick aside, anytime you find stuff like this, especially in CTFs, this isn't quite as applicable to real life sometimes, but especially in CTFs, try and use it wherever you can. Use it to try and log into accounts, use it to try and decrypt stuff that you have that's encrypted, use it to try and open a password protected zip, whatever. Even in the cases where you know that the password's usable for, say, a specific service or something, try using it other places also. Password reuse is a common thing you see, especially in these type of challenges. So I typically just start using it everywhere that I can think of. So first place I can think of that we have in this case is that the encrypted key. And so what we can do then is see if we can decrypt that using the openssl tools. So if we do openssl, actually I don't want to do this interactively. OpenSSL, I believe it is RSA, so we have an RSA key, and then it's our in file, which would be please subscribe.key. And our out file then would be, we'll just call it the typical RSA_ID. So we hit enter. It's going to ask for the passphrase. We'll try pasting in that heartbleed, believe the hype. So it wrote the key. I believe if that would have, let's see if I just enter in gibberish. Yeah, if you enter in gibberish, it'll fail to decrypt. So I think we are good. That was the password. Cat RSA ID. We can see now that we have a private key that's not encrypted. Just as a quick side note, you can use the encrypted key as is to SSH. It'll just pass or ask you for the passphrase, and we could put it in there. In this case, I just wanted to do it this way so you can see that you can decrypt these keys and then store them in an unencrypted fashion. So now comes the hardish part, not really hard, but of figuring out which account we're going to use to SSH in. So we could try SSHing as root. Before we try SSHing as anybody, for those that aren't familiar with this, SSH keys, they need to have specific permissions set on them. If they don't, then it won't allow you to use it. And so we've got a chmod 600 ID RSA. Or sorry, I don't know why I typed that backwards, RSA ID. And so now that the permissions are correct, we can use that. So we tried SSH-I, and we'll give it the identity of RSA ID, and root at, and this probably won't work. Well, I know this won't work, but just to show, 79. So it's going to try and use that key to establish a connection. The reason I say I know this won't work, even though I actually haven't tried it before, A, I know what account is set up with this key, but B, it would defeat the entire purpose of having these challenges with privesks if I was able to just log in as root directly. And so I don't know if they ever intended a way to enumerate for the user, but the way that I found the user was just some simple deduction. So in this case, the key that we found up on the website was called hype_key, so it seemed reasonable to try hype as the username. That was hype's key. So we try that. While this is waiting, by the way, you could have used Metasploit to perform the heartbleed attack as well. I was going to show that, but I don't know that it's super interesting to a lot of people. You basically pop open Metasploit, search for heartbleed. There's an auxiliary scanner. You load it up. You tell it to run after you give it the IP address of the machine. And it does essentially what we saw with the Python script, although it usually does a better job of dumping a large amount of contents from the web server. But in this case, it wasn't necessary. And so it looks like we were able to log in with Hype's account. So now we've got user access to the machine. And so if we just do a quick ls, it looks like this is an Ubuntu desktop box. We can tell that because it's got the documents folder, desktop downloads, yada yada. So it looks like this is an older kernel, 3.2.0-23. Let's grab our user flag real quick. And so to do that without showing too much, we'll just do an ls on desktop. Should be in there. It is. So if we do cat desktop, user.text to word count and count the characters, 33, which is our 32 character MD5 plus the new line character. And you can see the first 16 characters if I do a cut C1 through 16. And so there we've already got access to the user flag, and so now all we need to do is figure out how we're going to privesc to get to the root flag. And so let's change directories to somewhere a little less noticeable than the user's home. We'll do dev shm, which for those that aren't familiar is RAM drive basically. And then we'll make a directory, we'll call it Iceman. And the reason I put the period at the front obviously is so that it's hidden and it doesn't show up without somebody doing LSLA. Makes it slightly more difficult, although honestly I assume almost everybody does LSLA constantly to make sure that they're seeing even hidden stuff. And then so let's start serving out of our system. I'll switch directories to where I keep a lot of my scripts. Tools, scripts. Okay, so we'll start a Python web server here. So Python-m. We'll do simple HTTP server, and we'll do it on port 80. So what that's doing now is serving files out of this current directory on port 80. So if we switch back here, we should be able to do a wget http://10101415, which is my machine's IP address, and then linuxprivchecker.py. And we'll also get linuxprivchecker. linuxprivchecker.py. Okay, and then we can chmod and make those executable. And then let's run them both, and we'll just dump them to temporary files for now, I suppose, instead of looking at the output as it goes, although we could t it also, I guess. LinEnum to linuxprivchecker.txt, and that'll take a second to run. See if I've got any other interesting scripts in here that we would want to run. No. And then let's run linuxprivchecker. Python. That's done. So if we do linuxprivchecker, or sorry, linuxprivchecker.txt. Oh, they don't have them installed. linuxprivchecker.txt. It's got all the color codes though. Cat linuxprivchecker.txt. Okay. Scroll up. So we can see that the system, as we already saw, is running an older kernel, 64-bit. It looks like it is 12.04 precise. It's the LTS version. Hostname's Valentine. last time root logged on was February, so probably when the box was built. Only current user logged on is hype, which is going to be me. Yeah, my IP address. And let's see. Nothing super interesting. XDG session cookie. SSH clients from my address. Standard shells are open. Nothing interesting in cron jobs. Nothing super interesting on the networking other than for some reason this box has a bunch of different IPv6 addresses assigned to it. Which, honestly, I've actually never noticed on the other boxes if they have that many also. So, nothing super interesting in the processes. Listening on localhost 631, that's the internet printing port, I think, IPP. So that's related to cups. That's not interesting, I don't think. So I don't see a whole lot that looks interesting in here. So we can see in the Apache home directory all the stuff that we already found with the our scanner. Looks like they've got netcat installed. Okay, so let's see what we have in our other one, in the cat linuxprivchecker.txt. And a lot of the stuff that this shows is actually going to be the same. I think it does a little more checking for things like the word password and files. And biggest thing I think I'm interested in this one is going to be here at the bottom, where it looks for privilege escalation exploits that may work. A lot of these I have yet to see work most of the time. Most of them I think exploit different race conditions. One I don't see listed here, but that I know that we could try, is Dirty Cow. Dirty Cow tends to work on most Linux boxes that haven't been updated since late 2016-ish, I believe, is when they patched it. And so anything from before that time, which this should be well before that time, this version of Linux. Actually, let's see if we can find out when Linux into release 12.04. So 12.04 was released August of 2014, and it end-of-lifed April of 2017, so it's a pretty small window where somebody would have likely downloaded it but had actually patched. I mean, it's possible somebody patched along the way, but my guess is that they probably didn't, and so we can probably get away with Dirty Cow. So that would be the first thing that I try. You could also go to the link here for any of these exploits and download the POC code, compile it, and try it. But I have a tendency to like to go for things that I know have worked in the past. So Dirty Cow, I guess. And so what Dirty Cow is an exploit based on a race condition in the Linux kernel's memory subsystem. It has to do with the way that it handles copy on writes, which is where the word cow comes from. And so let's see, this is the page I've always seen for it anyway that has the exploit and the details. It's available at dirtycow.ninja. So we view the exploit. There's a bunch of different ones. I think this is the one that I typically try. So you can see here that the description shows different things that it tries to do. The one that replaces etc password with a file that gives you root is the ones that I've always used. So all of these etc password based root. Some of these may work, some of these may not. The only way to find out is to just try it. So we do raw, copy it, and in this window, let's kill this Python web server. Let's go back to our folder for Valentine, and let's make a that's not it. Let's try doing it this way instead. Okay, so we save that to Valentine. Okay, let's see. We'll call it cow. And so let's see, we're probably missing an import here. Let me look at that again. I think we might have. Yeah. Wait. I totally pasted the wrong thing here, it looks like. Oh, I did. Okay. I saved some message from Sublime Text, it looks like, instead. I say that looks like a little too many weird messages. Guess it does look like we're probably missing an import on something. So what I usually do if you don't know what import's missing is you can just do a quick Google search. Read a bunch of new sources. Seems like this is a common suggestion, is to put this flag in here. That worked to fix that error, but we do still have an implicit declaration of system. So if we repeat that. So it looks like we just need to include stdlib. Which I don't see in here. Looks like we're still getting another error. Built that time. By the way, I just thought of the fact that I should have taken a look here, because sometimes they're kind enough to give us, yeah, so at least the pthread flag, I would have gotten it. I just looked up here. And so now let's fire up another Python web server. For 80, and we'll grab that dirty cow executable. And then we'll chmod it. What this should have done is it should have, as you can see here, backed up the original user or the password file or executable to back up and replaced it with one that will give us a root shell if it worked. Now, for some reason, it always seems to hang on me, so I usually just Control-C out of that, and then let's try running it and see what happens. User bin passwd, and as you can see there, username is root now, so if we do who am I or ID, see that we're root, we're able to access root's directory now. And so we see our root flag, and we also see a curl.sh file. So if we cat root.txt and word count cut, so 32 characters plus the new line, we send it to cut-c characters, and we just get the first 16. That's the first 16 of the root flag. And just for curiosity's sake, let's take a look at what this curl.sh is. And so it looks like curl.sh is probably being called by a cron job or something, and it's running that post to the decode function that we were able to see by using heartbleed. So this is where that data that we were able to use to get the decryption key comes from. This is probably running in a loop, making sure that somewhere in the memory space of the web server we've got this data floating around, so that when you run heartbleed, you're able to get it and continue on. Early on the box, there were a lot of times where you could run heartbleed over and over and over and over again and get nothing, and so this probably either wasn't running enough, or people were doing something that was clobbering these strings out of memory and replacing them with something else. That seemed to be a big problem for a lot of people, is they ran it and they still couldn't find anything, and they couldn't figure out why. And so part of this machine was just pure luck. If you happen to get the right portion of memory when you made your attempt to perform the heartbleed attack. So before we close up, let's be responsible and clean up all of our mess here. First off is put back the original password utility, because we don't want to leave that there for anybody to be able to get root. So we cp temp bak to user bin passwd. And now if we call that just to make sure, and it asks for a new password, so that's working fine. And then if we clean up this directory, so we do an rm-r.iceman, that cleans up all of that stuff that I left behind. Something that people tend to forget to do on here. I think they get a little excited when they get the box done. They want to submit those flags and move on to the next one, and they leave stuff around. So please remember, try and clean up after yourself. Everybody appreciates it. It makes things more of a challenge for people because they don't stumble across the answer when it shouldn't have been there. So anyway, if you enjoyed the box, go ahead and give it a thumbs up. Feel free to subscribe or follow me on Twitter at @BenGrewell. And as always, shoot me questions on Hack the Box if you're stuck on something, and I'll do my best to get you pointed in the right direction. Have a great weekend or day or whatever day you're watching this, and I'll see you in the next video.